Hello friends, this is the third video regarding capacitance. Now, in this context, we will discuss about the grouping of capacitors. Why grouping is necessary? The aim of capacitor is to store energy or charge. If in a circuit, if you want to reduce the charge or if you want to increase the charge, then what type of a grouping is available? Because the standard capacitance or our desired capacitors are plentifully not available in the market. Okay, that's why we have to group by taking the capacitors which are available in the market. This is experimentally. Now, the grouping is in general two types. First is parallel grouping and the second one is series grouping. And in some circuits, partly parallel and partly series, you can assume as a mixed grouping. Okay, but in this video, we will discuss about some properties of parallel grouping. Now here I am taking C1, C2, C3 are three capacitors. They are connected in parallel. That means all the positive plates are connected together at one point and negative plates are together at another points. And these 2 points A and B, they are directly connected to the potential of the cell. That means if you move from positive terminal to negative terminal of the cell through C1 or through C2 or through C3, it is possible directly through one capacitor. So this is the parallel grouping, and this is also another mode of the parallel grouping. One can draw this or that. Okay. Now in the parallel grouping, one property is common. Each capacitor is directly connected to the cell, and hence potential across each capacitor remains same, and that equal to potential of the cell. Okay, each capacitor remains same, but suppose the cell provides a charge Q, and that Q distributes across C1, C2 and C3. If Q1, Q2 and Q3 are the charges across C1, C2 and C3, then the total charge supplied by the cell must be equal to Q1 plus Q2 plus Q3. Okay. Now here potential is a constant, capacitance is a variable, and charge is a variable. Therefore, if you take instead of 3, suppose if you take 2, okay, then I can write V1 equal to V2. This is so Q1 C1 equal to, you write Q2 C2. From this Q1 divided by Q2, that equal to C2 divided by C1. This is the formula. Q1 C1 equal to Q2 C2. From these two, you take any two, V1, V2, V2, V3, V3, V1. That is Q1 C1 equal to Q2 C2. Therefore, Q1 by Q2 equal to C2 by C1. That means in this case, capacitance varies inversely with charge. It is inverse ratio. Okay. Now, similarly, you can find out what is the value of Q1. What is the value of Q1? If C1 given, C2 given, then Q1 is equal to total charge given divided by equivalent capacitance. Okay, divided by equivalent capacitance whole into capacitance of the first capacitor. That means if charge is given Q, charge supplied by cell, Q2 is not given, you can find out Q1. Similarly, find out Q2. This is Q divided by C1 plus C2 whole into C2. It is possible. Okay. Now, with the help of this principle, you can calculate, that is Cp. Cp means equivalent capacitance. If a number of capacitors are in parallel, I am writing the equivalent or effective capacitance Cp as C1 plus C2 plus C3 like this. There are three capacitors, so you can take three. Okay. Now from that you can find out some formulas. From that you can find out some formulas. What are they? That is, for I am writing N capacitors. So Cp equal to C1 plus C2 plus Cn. This is written as a Ci. I equal to 1 to N. Again, for N identical capacitors, you write Cp is C plus C plus C up to N times. Okay, that equal to Nc. Okay, so these are the various properties regarding the capacitances of parallel plate capacitors. Okay. Now let us discuss about the series connection. In case of the series connection, negative plate of one capacitor is connected to the positive of the other, then negative of the second connected to the positive of the third, and that process repeats. That means if you want to go from positive terminal of a cell to negative terminal of a cell in the external circuit, you have to pass through a number of capacitors one by one. Okay, and this type of a grouping is called parallel grouping. In case of a parallel grouping, the charge remains the same across each capacitor. That means Q1, Q2 and Q3 are the each charges stored in C1, C2 and C3. Then Q must be equal to Q1 plus Q2 plus Q3. Q1 must be equal to Q, Q2 must be equal to Q, Q3 must be equal to Q. Now, if C1 differs but charge is same, therefore potential across each capacitor remains the same. If V1, V2 and V3 are the potentials, I am taking three capacitors, therefore sum of these three must be equal to the potential of the cell if there is no loss of electrical energy. Okay? Now in this case potential same, but here charge is same. Like this, if you take any two capacitor, if you take any two capacitor, charge same means C1 V1 must be equal to C2 V2. This shows that C1 by C2 that is equal to V2 divided by V1. So it is possible to calculate potential or capacitance partly through this formula. Okay. Now if total charge is given, that means here potential varies inversely with the C1, but their charge varies directly with C1. That is the difference. Okay. Now how V1 and V2 are related to the potential of this cell? This is V1 is V divided by C1 plus C2 into C2, whereas V2 is V divided by C1 plus C2 into C1. It is possible to calculate potentials across individual capacitors if there are two capacitors. Okay. So now if you use these two techniques, particularly these two techniques, then if you want to calculate what is the equivalent capacitance of the series grouping, I am writing reciprocal of equivalent capacitance is sum of the reciprocals of the individual capacitors. Therefore, in case of a parallel grouping, capacitance increases because it is a sum, but this is a sum of reciprocals. So, in series grouping, first property, in series grouping, equivalent capacitance decreases. This is the first point. Equivalent capacitance decreases. Now, second point is, for n capacitors, 1 by Cs, that is n by Ci, sigma, or you write in general sigma 1 by Ci. Okay? Now, for n identical capacitors, so 1 by Cs is n by C, so therefore Cs is C by n. Okay, Cs is C by n. Now, let us relate some properties to capacitor parallel and series connection. Some properties to parallel and series connection. Now, write another two properties here. This is another property I am writing for two capacitors. For two capacitors, so say C1 and C2. So Cs is written as C1 C2 divided by C1 plus C2. So it is possible to put the values directly or orally to solve the problem. Okay. Similarly, for three Cs is C1 C2 C3 divided by C1 C2 C2 C3 plus C3 C1. Okay. Now, for identical, another point, this is Cs for identical capacitors. First in series and then parallel. Suppose they connected first in series, then they are connected in parallel. In that case, in case of a series, this is C by N. In case of a parallel, this is NC. So therefore, Cs into Cp, that equal to C square. Cs into Cp, that equal to C square, and Cp by Cs, that equal to N square. That is, if individual capacitors are not given, direct a question is given. Suppose 10 identical capacitors first connected in series, then connected in parallel. Okay, then N is 10, Cp is given, Cs is given. So find out the value of C, or find out the value of N if C is given. Find out the value of Cp if Cs or N are given. So these are the various properties to solve the problems or entrance formulas. These are the formulas. If you like this video, like it and share it. Subscribe it. Thank you all.